filtered out. So remember this thing. So note that we are saying that if something evaluates to true, only then the select operation filters them out to your new relation, right? So what happens when a particular balance is null? So what is null greater than equals to 300? Again, null, right? We have no idea what that resultant value is. So if P evaluates to with an unknown value, it would evaluate to an unknown value for the tuple as well. And that particular tuple is going to be excluded from the result. So if the predicate P has, for example, balance greater than 300 and we have a null balance for someone, that particular balance will not be evaluated and not be returned. Natural join. So basically that means that a natural join was a Cartesian product that selected those relevant details that we were talking about that had those attributes common across both of them. So if a common attribute has a null value, those tuples, again, we are comparing those two things. The same rules apply for equals to null and basically the Cartesian product. So those tuples are excluded from the join result as well. So this should be quite easy enough to understand because it has a select and select does not use those null values. And so essentially those tuples are excluded in your natural join as well. Because we used a Cartesian product and a select to create a natural join, so those rules apply. So essentially because null equals to anything evaluates to unknown. Okay. So up to now makes sense so far? So no arbitrariness yet, everything should make sense yet. But now the next thing that we are going to talk about will introduce some arbitrary implementations about this null value. So mainly we are going to talk about the project operation or the project operation, right? So the project, what was the project operation? Give me the rows, sorry, give me the columns for a particular table. So get me the balances of all my bank accounts, right? So that would be a list of all balances in my account. And remember that a project operation would always eliminate duplicates. So if I project down the customer names, I would only get unique customer names, right? Because it's a set. Now, in a project operation, our null value is treated like any other value. So if we have a null value in your column, that null value stays in your output schema, right? If there are multiple null values in your column, that means that those null values are going to be deduplicated and you would only have a single null value because it's a duplicate thing. But at the end of the day, you would still have a null value there because project treats every other value like, I mean, a null value like any other value. Okay, so that is the first arbitrariness that you would find in your databases. Unions, intersection, and difference. So a null value is treated like any other value for either unions, intersections, or differences. So that means that if I perform a union operation on multiple tables, if there are multiple null values, those get deduplicated into a single value. However, the null value does stay in your final union result. Same applies for intersection and same applies for difference. So these choices might seem somewhat arbitrary, but you can imagine that if at any point in time, if we could sort of have some meaningful result with a null value when we are performing that operation. So for example, we would want to see if after projection there is any row that ever had a null value, right? So that does make sense. Even for a union operation, we would want to know that we would not want our union operation to discard on null values, right? We would want that in our final table because we are uniting two different relations. So if it makes sense, the database implements it in such a way that those null values are there. If it does not make sense to the database, it would usually remove them from the result. So a select and arithmetic operations and those things, the database removes all null values, right? So when we were talking about arithmetic operations, remember that, so I do talk about it in the next part. Yes, for example, in terms of grouping, remember grouping and aggregation with that fancy G thing. So in terms of grouping, null values are treated like any other value. That is your project thing all over again, right? Because If there is a null value, it is basically grouped together into a single null group, right? Or a single group. So all null values end up in the same group. Aggregation phase of your grouping and aggregation. Um, well, it depends. Okay. So when we are summing up certain set of values, so again, let's say 5 plus 8 plus 7, blah, 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 plus null. If we are performing the sum operation, then the sum operation would remove that null value and just add up all those values. So 5 plus 8, what was that? 13 plus 7, 20 plus null. In your sum group, aggregate operation, it would result in 20. It would discount all the null values there and just give you the sum value. So you can imagine that, let's say that I have a table of student scores, and I just say out of 60 students, I just computed the first 30 student results or some 30 student scores. I would want to have the average values of the scores so far, and all of the unscored students still have a null there. I would still want an average from that list. So in that particular scenario, summation, average, and max and min and those things would actually get me the the sum or the average of the true values without the null values. Okay. So every aggregate operation has a slightly different arithmetic behavior. Um, so for example, let me give you one example where two database implementations slightly differ. So MySQL and Oracle differ in this thing. So for example, let's say the sum of all empty null sets. So a set that contains only nulls. What do you guys think would be the result of that particular summation operation? That is the sum of all null values. Should it be a zero? Should it be a null? Guesses. I mean, if you were designing a database, what would you do? If I have, let's say, 5 null values, I want to sum them up. Would you return the result as 0, or would you return the result as null?
Be a null, wouldn't it?
We have one answer for null, and Taha says it's a 0. So one of you is basically the follower of MySQL. The other one of you is basically the follower of Oracle. So both of those database implementations implement that sum operations in those two ways.
I'm just guessing.
Yes. So essentially that was the case. It makes sense to, for example, for some of the aggregate operations to behave like this. So for example, let's say that the min operation that has some null values, I can return a null for that. But it really does not make sense for some operation for all null values to return a null. I would have preferred if it returned a 0, but MySQL returns a null. Okay, so keep that in mind when you are using different types of database implementations. One exception of those aggregate functions is the aggregate function for count. So if we have an empty null set, the count would return 0 for most database implementations, almost all database implementations, right? So if I count an empty null set, I would get a 0. Okay. Then we also have the generalized projection operation. Remember what was generalized projection? It was basically projection, but projection with columns where we could have some arithmetic operations within those columns as well. So for example, we looked at the example where we wanted to compute the available balance of every customer, given that we have a credit balance, a credit amount and a balance amount for each customer, right? So a generalized project was where we could use the customer name, comma, credit balance minus the actual balance to get the actual remaining amount, right? So that was generalized projection operations. Again, what does it use? It uses simple projection operations. So what does simple projection do? It allows null values in your final results, right? If there are duplicates, it removes those duplicates, but essentially it still allows null values. And it can perform arithmetic operations on those projected results. So that means that arithmetic operations do not really like null values. So if there are null values there, it results in null values as well. So it's pretty easy to figure out from the previous rules that a generalized project operation would also follow the same rules as that of project, right? Okay. Similarly, outer joins that we have talked about, they pretty much behave the same as natural joins, except padding missing values with null, right? Now, coming back to our clutch box problem. So we had these two relations, completed and puzzle list, and we suddenly got this new puzzle that was clutch box. Now, we want to have the case that for every puzzle name, so how many people have completed each puzzle. So we would want to group by puzzle and then count the number of people, right? So we want to do a join. We know that a natural join won't work because clutch box does not occur in the puzzle name for your completed list, right? Now, a left join will work in this case, right? A left outer join will work. So if we perform a puzzle list, left outer join completed, we see that what does it mean to have a left outer join? So every attribute in the left-hand side of this relation, that is in puzzle list, every attribute in puzzle list, every tuple in puzzle list needs to be present, right? So we see that we have this entire list again. And now with a left outer join, we have this clutch box with a null value as well. Because clutch box is there in puzzle name, but it is not there in the completed list. So clutch box gets a corresponding person name value of null. Does that make sense? Any questions? Who's already getting lost? Okay, so if this makes sense, would a right outer join work for the same case? For this particular case, would a right outer join get me clutch box null? Yes or no?
No.
Why?
Is it because it's missing on the right side?
Right. So if it's a right outer join, exactly, you're correct. A right outer join basically means that if a puzzle name exists in the completed list but does not exist in my puzzle list, then it stays. But if it's not there, clutch box will not be there at all. Right. So if we just quickly go back to that thing, a right outer join, remember that A was not in my second list. And that is why A was not part of my final relation as well. So you're correct, Jesus. So a right outer join will not work for this case. Would a full outer join work? Yes or no? I have one answer from How, and none of you are actually turning on the cam. Yes, thank you. Yes, a full outer join would still work in this case because clutch box is there and clutch box would come in there. Good answers. Okay. So now, if we have this particular join operation, then we can actually do the same thing that we did earlier. Group by puzzle name and then count the people, right? So essentially group on the puzzle names, count the number of people that have completed these puzzles,